Hello friends, welcome to follow up. Today let's have a look at problem 49, group anagrams. In this video, we're going to explain a method or idea to solve this problem. So we are going to use vector representation. So first, let's look at the problem statement. So here we are given an array of strings called strings. So we want to group the anagrams together, so we can return the answer in any order. So here an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So here, if you look at the first example, so the first example actually is more general, right? So here example 2 and example 3 can be regarded as edge cases. So here we know EAT and TEA and ATE are anagrams, so we put them together. So similarly, we have TAN and ANT, right? So these two are together. So also we have BAT, so this just a single group itself as a sublist. So here the constraints are the following. First, the strings as a list, the length is bounded above by 10 to the power 4. And each element or each string in this list, its length, the length is bounded above by 100. So here, the strings consist of lowercase English letters. So this one, or this constraint, is very essential for our problem-solving strategy. So here, I'm going to use a vector representation. So for each string, so I'm going to use a vector of the 26th dimension to represent it. For example, I have a string that is A, so I'm going to represent it as 1, then with 25 zeros, right? So here I'm using 26 dimensional vector due to the fact that we have 26 letters. So each position will be the frequencies. For example, here A, so I'm going to have 2 here, right? So this is the general thing. So typically, if you have say AAB, so you are going to have something like this, 2, because A appears twice, so B appears once. Then you have some zeros, right? So for two anagrams, as long as they're for two strings, as long as their vector representations are the same. In other words, the letters have same frequencies, so they can be anagrams. So they actually form anagram relation. So for this problem, for example, you see both EAT and ATE or TEA. So right. So we are going to have something like this. So the position for A is 1. This is for B, for C, for D, for E is also 1. Then for T is also 1, right? Then you have zeros. So they have the same representation, right? So here I'm going to use, you can see we can use list, but here I'm going to use tuple, because the tuple is immutable, so which can be used as a dictionary key. So next I'm going to write the code, and then in between we're going to explain the logic. And also, once you see the code, you can quickly digest the whole idea. So first, I'm going to use collections default dictionary. I'm going to use a list, right? So in other words, if you want to retrieve, use a key to retrieve value. If key is not in the dictionary yet, then the default value will be an empty list, right? And then let me first do this. Let me first define a representation, right? So let's write a hyperfunction. So vector representation given a string, right? So I'm going to return a 26-dimensional vector. Let's do something like this, 0 to 26. So here I'm going to use list, because list is mutable, so that we can modify the elements. Then I'm going to iterate over for character in S. Then A corresponding to the 0th index, right? So you can think what we want to do is, so result So this position is ordinal number of this character minus that of the character A. So for example, if your character is A, so then these two cancels, you are going to get index 0. But if your character is B, so then the difference here will be 1, right? So this one, I'm going to increment by 1. So this way, you have this vector representation. So here I just return it, or you can just make a tuple outside this one. The reason we use a tuple because we want to use this vector representation as keys in the dictionary. So this is the first one. This is the hyperfunction to represent a string, right? So this is 26-dimensional vector. So next, so the problem logic, right? So problem logic. So for this, I'm going to iterate over the string. So for s in strings, right? Then first we can get its vector representation, right? So basically, the vector representation will be, so we call this function vector representation of s. So as we have transformed this one to be a tuple, so here this key is a tuple. Because tuple is immutable, we can use it as a dictionary key. Then we can append this s to the corresponding list, right? In other words, the same vector with a list value. The list value will be the corresponding groups, right? So once we have this, we are basically done. So we just need to return the values of this dictionary. So we just need return the values. But this is a values object for a dictionary, so we can make it a list, right? So this actually forms a solution format to this problem. Let's do a quick test. Yeah, it passes the first one. Now let's look at the generic case. Yeah, actually, I guess for this one, though, you know, the return type is a list of strings. So if you do not use list, it might also pass. Let's see. Yeah, it passes, right? So basically, this is a very direct question. So here, if you haven't practiced much about anagrams, you can see some similar questions. So here, we can see more. See one more. Let's see this one. So if you want to find if two strings are anagrams, so basically you can check their unique letters and the corresponding frequencies. So here, for this problem, right? So we want to see if their lengths are not equal, right? So they can't be anagrams, so we return false. And then we count the unique letters and their frequencies. So now, because we have done this check, we can just iterate the case from one of S or T. Here, let's iterate over S, right? So, and then if these two are not the same, so here I use the get, because we are not sure if this K is a K in T, right? So we use this get to get its frequency. And if K is not yet a K in T, so we're going to set the default value 0. So in this case, because the corresponding letter has different frequency, we return false. Otherwise, after this for loop, if nothing returns, we're going to return true. So this is a very typical anagram problem. You can also test this one. Yeah, it passes all the cases. So with that said, I guess we finished 2 problems about anagrams. So there are more problems you can practice. For example, this one is the one we just finished. So with that said, I guess that's about it for this video. Thank you for watching.